हेलो एवरीवन।
जी सर।
हाँ, तो आप ऐसा करें कि अपना जो माइक्रोफोन है वो म्यूट पे रखें। Actually, subject name is the heat transfer, and I have listed some books, and you can take help from these two books. I have mentioned here heat transfer, the fundamental and applications. It's a fourth edition by the Eunice A. Sengel. It's a very familiar book of heat transfer, and another one is the process heat transfer by the Donald Q. Kern, and so both editions are both books are very familiar. And if you want to take any sort of help uh, after the presentation, if you are following these two books, any one of these two books, you can get help and get the conceptual studies as well as the problems. So let's start introduction about the subjects and basic concepts. Also, introduction about myself. My name is Suhail Aman, and I have done my bachelor's in chemical engineering from Mehran University of Engineering Technology, Jamshoro, and my master's from NAD University of Engineering Technology, Karachi, and my PhD is in progress. And I'm doing my PhD from Changzhou, Datashui, Changzhou Dong University, China. So, especially in this presentation, we will learn about the basic concepts and introduction about the heat transfer. So, our main objects about the course would be understand how thermodynamics and heat transfers are related to each other. What is the difference between the thermodynamics and heat transfer, and we can study here how the thermodynamics is related to the heat transfer. And secondly, the distinguish thermal energy from the other forms of energy and heat transfer from other form of energy transfer. And then the perform general energy balances as well as the surface energy balances. Uh, General energy balances means we will apply the some energy balances and we can calculate the and we can resolve the some heat relevant problems, and then understand the basic mechanisms, because the heat transfer is basically depends on the three main mechanisms through which the heat is transferred. There are conduction, convection, and radiations, and after these mechanism, I can say there are some laws that are relevant to those mechanisms, like Fourier law, that is totally concerned to the conduction, and Newton's law of cooling, that is concerned to the convection, and Stephen Boltzmann's law of radiations, that is concerned with the radiations. And after that, I can say next slides we can study about we can study all these laws and I can say mechanisms in details. So another one is identify the mechanism of heat transfer that occurs simultaneously in practice, develop an awareness of costs associated with the heat losses, and solve the various heat transfer problems encountered in the practice. So all these are the objectives we will discuss here in this presentation. Title is the thermodynamics and heat transfer. So what is the thermodynamics and what is heat transfer? What is the difference between the thermodynamics and heat transfer? So before going for the differentiations between the thermodynamics and heat transfer, so let's start some introduction about the heat. First of all, we have to know about the heat. What is heat? From the early education till to the undergraduation, and I can say higher education, we are studying in listening about the heat, what is the heat, and we have studied in early education also. So heat is a form of energy that can be transferred from one system to another system as a result of temperature difference. So actually the heat is nothing, just a form of energy and can be transferred from one system to another system. So here the term used here is a system. So first of all, we have to know about what is a system. So Actually, anything that is under consideration is known as a system. So system means, for suppose we are assuming that there are two bodies, one body having the high temperature, another body having a low temperature. Then heat will be energy will be transferred from the body having the higher temperature to the body having the lower temperature. So if the both bodies have the same temperatures, if the both bodies have the same temperature, it's not possible to transfer the heat from one body to another body. We can say both bodies are in equilibrium position. So when two bodies are in equilibrium positions, it is not possible the transformation of an energy. So transformation of energy only occurs when there is a temperature difference between the two bodies. Two or more than two bodies, it's not necessary. We only take the two bodies in considerations. So it is not necessary. We may take more than two bodies as well. But main thing is that the temperature difference between these two bodies. If there is no temperature difference, there will be no transformations of an energy. Secondly, there is a thermodynamics. So if we look at the thermodynamics word, it's a combination of two words, thermo and dynamics. Thermo means heat and dynamics means motion. So, or I also can say the movement. So simply, if we take the definition from these two wording, so thermodynamics, we can say the moment of heat is known as thermodynamics. But in other words, I can say, but the actual definition is that the thermodynamics is concerned with the amount of heat that is transferred as a system and undergoes a process from one equilibrium state to another equilibrium state. So again, the word system is used here. So system, as I have already defined, that system is the thing that is already in our consideration, or the thing that is under consideration is known as a system. So if I take an example, right now I am delivering a lecture. So uh, I am delivering the lecture via Zoom meetings, and I am using the internet services. So my considerations are the things that are my consideration is Zoom software and internet services. If I don't have any one of them, I cannot deliver the lecture. So I can say the system is I can say both I can say both Zoom and also the internet services are under consideration. So that's my system right now. But if I take another example, like I have any container, any container. So walls of containers I can consider as a uh, I can consider it as a boundaries, and outside the boundaries I can say it's a surrounding, and inside the boundaries is known as a system. So let's take an example, real examples. In the end of this presentation, I will show you some videos and I can see some pictures, so you can understand easily what is a system. So another one is the heat transfer. The heat transfer is a very simple definition. Heat transfer, thermodynamics is a branch of physics, and heat transfer is a branch of thermodynamics. And there is a transformation of energy from one body to another body. I can say there is a transformation of heat from one body to another body. How heat is transferred? Similarly, as I have defined in the definition of heat, that the transformation of energy. But here in heat transfer, transformations of heat from one body to another body. So heat will be transferred if and only if there is a temperature difference between two bodies. So the definition deals with the determinations of rates of such energies transfers as well as the variations of temperature. And another definition is the transfers of energy as the heat is always from higher temperature medium to the lower temperature one. As I have already defined, that heat will be transferred. Heat is it's a natural law, it's a natural consideration, it's a natural thing. The heat will be transferred from the higher temperature medium to the lower temperature medium. Media means we can say a body, a thing, having the temperature higher in another body. For example, we have body A and body B. Body A has the 30 degrees centigrade and body B has the 20 degrees centigrade. Then temperature will be transfer. Heat will be transferred from the body A to B because A have the 30 degrees centigrade and B have the 20 degrees centigrade. So temperature will be transferred from 30 to 20 and it will be continuously transferred. Heat will be continuously transferred from 30 to 20 degree centigrades until and unless both bodies temperatures comes equal to one another. यानी ये मैं कह सकता हूँ कि अगर दो जिस्म है, एक जिस्म ए है, जिस्म बी है, एक का जो है वो 30 डिग्री सेंटीग्रेड टेम्परेचर है, दूसरी का जो है वो बी का जो है वो 20 डिग्री सेंटीग्रेड 30 से 20 की तरफ जो है वो हीट ट्रांसफ़र होगी और हीट ट्रांसफ़र होती रहेगी जब तक दोनों बॉडीज़ का जो टेम्परेचर है वो इक्वल ना हो जाए। जब इक्वल हो जाएगा और जिस पॉइंट पे वो इक्वल हो जाएगा उस पॉइंट को हम कहते हैं यानी इक्विलिब्रियम, हीट ऑफ इक्विलिब्रियम या इक्विलिब्रियम कह सकते हैं उसको। और इक्विलिब्रियम जब पोजीशंस पे आ जाता है तो यानी फर्दर जो हीट गेन एंड लॉस होती है जहाँ हीट ट्रांसफर होती है वो नहीं होता फर्दर यानी स्टॉप हो जाता है heat transfer stops when the two mediums reaches the same temperature similarly as I have already defined the when the temperature of two media reaches to the same position or same level a same temperature level so there will be no further transformations of energy or heat from one body to another body. It can be transferred in three different modes or three different mechanisms like a conduction, convection, and radiation. So conductions happens in all three states of matter, like solid, liquid, and gases. And convection only happen in heat can be transferred, especially in convections, only in liquid and gases. In radiations, heat can be transferred in radiations in the form of radiations only in gases यानी कंडक्शन जो है वो हीट ट्रांसफर होती है कंडक्शन में यानी हीट कैन बी ट्रांसफर विया कंडक्शन चाहे वो लिक्विड हो चाहे वो गैसेस हो चाहे वो सॉलिड हो ठीक है कन्वेक्शन में क्या होता है कि सिर्फ वो लिक्विड एंड गैसेस में ट्रांसफर होती है और रेडिएशंस में क्या होता है कि सिर्फ वो यानी गैसेस स्टेट में अगर कोई भी चीज़ होगी या मीडिया होगा तो उस तब जो है वो हीट यानी ट्रांसफ़र हो सकती है सिंपल सा एक एग्जांपल है जिस तरह से सन जो है वो कंटिन्यूसली रेडिएशन जो एमिट करता है ठीक है कंटिन्यूसली रेडिएशन से एमिट करता है और वो कहाँ से पास होते हैं यानी एयर से पास होते हैं तो एयर के ज़रिए ही जो है वो यानी सोलर एनर्जी जो है वो कन्वर्ट होती है या ट्रांसफ़र होती है फ्रॉम वन प्लेस टू अनदर प्लेस ठीक है यहाँ पे फॉर सपोज के ज़मीन का जो टेम्परेचर है अर्थ का वो कम है एज़ कम्पेयर टू द सोलर तो क्या होता है कि वहाँ पे जो सोलर सिस्टम का जो टेम्परेचर है वो ज़्यादा है यहाँ का कम है तो वहाँ से हीट जो ट्रांसफ़र होगी यहाँ पर बाय एयर एयर उसका क्या होगा मीडिया होगा चाहे वो सॉलिड हो लिक्विड हो गैसेस हो इसको मीडिया कहते हैं ठीक है तो रेडिएशन में हमेशा रेडिएशन यानी हीट जो ट्रांसफ़र होगी रेडिएशन में सिर्फ वो गैसेस स्टेट में हो सकती है कन्वेक्शन यानी लिक्विड एंड गैसेस में होती है कंडक्शन सिर्फ कंडक्शन इन थ्री स्टेट्स ऑफ मैटर में होती है यानी चाहे वो लिक्विड हो गैसेस हो या सॉलिड हो further if we talk about the difference between the heat transfer and thermodynamics so heat transfer is a time dependent I can say time dependent quantity है यानी हीट ट्रांसफर जो वो टाइम डिपेंडेंट है वो टाइम पे डिपेंड करता है यानी टाइम के साथ साथ अगर हीट दो जिस्म में हीट ट्रांसफर होती है बॉडी ए से बॉडी बी की तरफ तो ये टाइम के साथ साथ यानी ट्रांसफर होती रहेगी और स्लोली एंड ग्रेजुअली उसका जो ट्रांसफरिंग रेट है वो डिक्रीज होता जाएगा ठीक है तो ये टाइम डिपेंडेंट क्वांटिटी है ठीक है यानी हीट ट्रांसफर टाइम डिपेंडेंट क्वांटिटी और इसको हम मेजर कर सकते हैं किलोवाट से और थर्मोडायनेमिक्स जो है वो टाइम पे डिपेंड नहीं करती और इसका जो यूनिट है यानी वी कैन कैलकुलेट द थर्मोडायना वी कैन मेजर द थर्मोडायनेमिक्स इन किलो जूल्स so if we consider simple definition of heat transfer especially in this slide the transformations of energy from body Having the high temperature to the body, having the low temperature is called the heat transfer. And as I have defined in previous slides, it can be transferred only in conduction, convection, and radiation. And thermodynamics, the simple definition is a branch of physics, or we can say it's a branch of science as well also. So that deals with the study of energy interactions with the system with respect to surrounding. Its net effects and properties associated with the system is called the thermodynamics. So I have already defined about the system. What is the system? So I can say there are three major types of system. डेफिनेशन तो मैंने पहले ही बता दी कि कोई भी चीज़ अगर अंडर कंसिडरेशन होती है उसको हम सिस्टम कहते हैं तो सिस्टम के जो मेन यानी टाइप्स हैं वो तीन यानी मेजर टाइप्स हैं सिस्टम के एक होता है ओपन सिस्टम दूसरा होता है क्लोज सिस्टम और तीसरा होता है आइसोलेटेड सिस्टम ठीक है ओपन सिस्टम में क्या होता है कि यानी अ, उसमें मास भी ट्रांसफर हो सकता है हीट भी ट्रांसफर हो सकती है यानी इन ओपन सिस्टम heat and mass both can be transferred. In the closed system, only heat can be transferred, but mass cannot be transferred from system to surrounding. An isolated system, neither mass nor energy. Both, I can say, both cannot be transferred from the system to surrounding or surrounding to system. So, and what is the surrounding? Uh, the things that are outside the boundaries is known as surrounding. And the combination of system surrounding is known as system surrounding and boundaries is known as universe हम उसको यूनिवर्स कहते हैं यानी चाहे वो सिस्टम सराउंडिंग और अगर बाउंड्रीज के कॉम्बिनेशन को हम कहते हैं कि या यू सिंपली कह देंगे द सम ऑफ सिस्टम एंड सराउंडिंग इज नोन एज यूनिवर्स इसको हम यूनिवर्स कह सकते हैं थर्मोडायनेमिक्स प्रॉपर्टीज का यहाँ पे तस्करा हुआ तो थर्मोडायनेमिक्स प्रॉपर्टीज वो कौन सी होती हैं जिस तरह से कंप्रेसिबिलिटी है डेंसिटी है स्पेसिफिक एंट्रोपी है प्रेशर है एक्सटेंशन we have taken in two example here as I have already defined about I have defined something about the different type of system so if I talk about this picture uh, hot cup of coffee having the temperature about 70 degrees centigrade this is a this is open system this is the example of open system the outside the temperature I can say outside temperature is about 20 degrees centigrade and the inside temperature of a cup or mug is about 70 degrees centigrade so heat will be transferred from mug to the surrounding from because the mug temperature is 70 degrees centigrade and the surrounding temperature it means that the cool environment temperature is about the 20 degrees centigrade so heat will be transferred from a hot cup of coffee to the surrounding. Arrow is already showing, especially in this picture. So if we read about the title of this figure, heat flows in the direction of decreasing temperature. It's a natural phenomenon. And in real world, heat can be transferred from higher temperature body to the lower temperature body. There is another example, figure 1-1. We have taken the example of thermos bottle and it's insulated and there is a hot coffee as I have already taken same example in a previous figure because hot coffee we have taken in mug but right now we have filled the hot coffee in thermos bottle and walls of bottles are insulated and if the walls of bottle are insulated then it's closed by the I can say cape. So neither heat nor mass can be transferred from the thermos bar. कप में क्या होता है कि हीट भी ट्रांसफर होगी और ऊपर से आप देखेंगे ये वेवापोरेशन हो रही है यानी वेपर्स आर फ्लोइंग आउट फ्रॉम द मग ऑफ कॉफी so it means that mass is also transferred and heat is transferred via boundaries of mug आपने देखा होगा कि मग को जब हम कॉफी का हो चाहे वो चाय का हो when we are touching to the mug we are feeling some sort of heat So it means that heat is transferred from the mug to an surrounding. But in thermos bottles, it is, I can say, it's insulated, so heat cannot be transferred. Transfer. अगर आप किसी भी कोई भी अगर मग हो चाहे बॉटल हो चाहे थर्मोस हो और वो इंसुलेटेड है अगर आप उसको टच करके देखेंगे तो आप यानी हीट महसूस नहीं करेंगे उसका रीज़न ये है क्योंकि वो इंसुलेटेड है अगर इंसुलेटेड बॉडी होगी तो उससे टेम्परेचर यानी हीट जो है वो रिलीज नहीं होती तो और वो बंद है तो इसलिए यानी मास भी ट्रांसफ़र नहीं होगा और इसको हम कहते हैं कह सकते हैं कि ये जो एग्जांपल है थर्मोस वाला ये यानी आइसोलेटेड सिस्टम है और क्लोज सिस्टम में क्या होता है सिमिलरली वी हैव टेकन द एग्जांपल प्रीवियसली वी हैव टेकन एन एग्जांपल ऑफ हॉट कॉफी हैविंग द टेम्परेचर 70 डिग्री सेंटीग्रेड अगर इस कप के ऊपर अगर केप रखा हो या कोई ढक्कन रखा हो या कोई बर्तन रखा हो तो उससे क्या होगा कि मास कैन नॉट बी ट्रांसफर मास जो है वो ट्रांसफर नहीं होगा ओनली हीट कैन बी ट्रांसफर फ्रॉम सिस्टम टू एन सराउंडिंग सो if the system in which there is transformations of heat from system to its surrounding and there is no any transformation of mass is known as a closed system उसको हम closed system कह सकते हैं so there are there are three main type of system one is a open system closed system and another one is a isolated system let's study about some historical background about the heat transfer of heat so first of all let's study about the kinetic theory. What is the kinetic theory? We have already studied in the second, I think, in the chemistry book of 11th grade, and also we have studied in the middle education, early education. Well, you may also studied in science as well as in physics and other subjects. So, kinetic theory is defining that molecules are tiny balls you can consider treat means you can consider molecules as tiny balls that are in motion this possesses a kinetic energy anybody uh, anybody that is uh, that is in a state of motion we can say it has some sort of kinetic energy अगर कोई भी जिस्म मोशन में है यानी वो स्टेट ऑफ मोशन में है मूव करता है यानी अपनी लोकेशन चेंज करता है पोजीशन चेंज करता है मोशन का मतलब ये होता है कि यानी एनीबॉडी दैट चेंजेस इट्स पोजीशन इज नोन एज मोशन तो कोई भी अगर जिसे में वो अपनी पोजीशन चेंज करता है तो उसका मतलब ये है कि यानी उसके अंदर काइनेटिक एनर्जी अवेलेबल है तो ये काइनेटिक थ्योरी इज डिफाइनिंग द molecules treat the molecules as a tiny balls and that are in a state of motion and this possesses the kinetic energy and kinetic theory also defines that explains that the size of molecules is smaller than the space between two molecules काइनेटिक थ्योरी ये भी डिफाइन करती है कि जो साइज होती है मॉलिक्यूल्स इतने तो छोटे होते हैं कि दो मॉलिक्यूल्स के दरमियान जो साइज होती है यानी डिस्टेंस होता है उससे भी कम साइज के मॉलिक्यूल्स होते हैं then heat the energy associated with the random motion of atoms in molecules is known as heat we have already studied in the previous slides now let's take some introduction background historical background of the caloric theory so before moving towards the caloric explanation of caloric theory we need to look at figure 1 to 4 in the early 19th century heat was thought to be an invisible fluid focus upon the words invisible fluid called the caloric that flowed from warmer body to cooler ones. ये 19 यानी अर्ली 19 सेंचुरी तक ये कॉन्सेप्ट चला आ रहा था कि हीट जो है एक इनविजिबल फ्लूइड जिसको हम देख नहीं सकते मगर यहाँ पे इसने एक वर्ड इस्तेमाल किया फ्लूइड हीट इज अ इनविजिबल फ्लूइड इसको आप फोकस में रखिएगा गौर पे रखिएगा कॉल्ड द कैलोरिक इसको हम कैलोरिक कहते हैं that flowed from warmer body to an cooler ones. यानी एक natural phenomena है, जिस तरह से मैंने बताया, तो warmer body यानी body having high temperature can heat can be transferred from the body having high temperature to the lower body having the lower temperature. But it was a mistake till to the early 19th century. They considered previously, I can say, scientists considers the heat is an invisible fluid, but in the real world or in the reality, heat is not an invisible fluid. Well, so we can study, we can take the further conceptual studies in caloric theory. So look at the figure. There are two, I can say, bodies, body A and body B, and body A have high temperature. I can say it's a hot body, and there is another body, cold body. So both bodies are in close contact to one another. Both bodies are in close contact in one another. So heat will be transferred from a hot body to the cold body because the hot body have the high temperature and the cold body have the low temperature. So that's why the heat will be transferred from hot body to the cold body. So in the form of caloric, uh, well, this is a, I can say, old conceptual study. So let's study about the caloric theory. Heat is the fluid like a substance called the caloric. कैलोरिक थ्योरी ये डिफाइन कर रही थी कि हीट जो एक फ्लूइड है और जो सब्सटेंस की तरह है जिसको हम कैलोरिक कहते हैं दैट इज मासलेस have no any sort of mass colorless have no any sort of color odorless have no any sort of smell or any यानी कोई किसी भी किस्म की कोई भी स्मेल नहीं है खुशबू नहीं है ना कोई बदबू है यानी odorless है एंड टेस्टलेस हैविंग नो एनी sort of taste यानी जायका भी नहीं है that can be poured from one body to an other body जिसको हम एक बॉडी से दूसरे बॉडी में जो है वो डाल सकते हैं it was only in the middle of 19th century that we have a true physical understanding of nature of heat and careful experiments after that the careful experiments of the Englishman James P. Jones published in 1843 convinced convinced just a moment.